Hi students, welcome back to the lecture. It's a second lecture of inequalities. In this lecture, solving inequalities seems like a difficult one, but I want to assure you guys that the solving inequalities are not so difficult to solve. There are few things that we need to keep in our mind to solve this linear inequalities. We will see everything about solving the inequalities step by step in this lecture. Solving inequalities contain three steps. So you need to understand three basic steps to solve any linear inequalities. The first step that we are going to explain, we'll see this first point using an easy example. That is, example, let's have x minus 2, x minus 3 is greater than 0. Let's observe the rules. The first rule is to make this inequality in a linear form. So it must be in a linear factor or linear form. That is linear, and the right hand side will be 0. As you can see, this equation hold the first rule. This is the linear form and the right hand side is 0. The second rule says that we need to find the critical points of the linear expression. The critical points, that is x minus 2, if that is 0, then the critical point will be 2, and x minus 3 is equal to 0, x will be 3. So the critical points of x will be 2 and 3. And we need to plot this number in a number line. So let's have a number line here. Let's suppose this is 0, this will be 2, and this will be 3. So you need to plot this thing in the second rule. What is the critical point in case of saying this critical point? We will explain this later. What is the critical point? After solving the equation, we will see why we say this 2 and 3 are the critical points. In the third point, in the third rule, we need to identify the solution region. In which the x is satisfied. That is, we need all the x which will satisfy this expression. This expression must be positive because it's simply showing that this expression is greater than 0. That simply means that is the expression is a positive number. Now the exciting part, let's solve the equation. Solution, that is x minus 2, x minus 3, which is given that is greater than 0. That is given, and easily you can see in the first step that this expression is in linear form and the right hand side is 0. In the second point, we need the critical points. As we know, the critical points is 2 and 3. So in this second point, we need to know the critical points and plot in the number system. So let's plot in the number system. So this is the number system where this is 0, this will be 2, and this will be 3. There are few more things you need to know while solving these type of equations. You can see I'm creating a round shape here. This means exclude. So while solving this type of equation, you need to understand two things. That is, these symbols contain exclude and this symbol contain include. Okay, that means if I draw this symbol on a number, then the number is include the series, and if I draw a hollow round shape, then the number will exclude from the system. So here we simply see that this expression must be positive. So we need to find out the positive section region in this number system where all x, for all x, this expression will be positive. Let's have the 2 number. If I plot this 2 here, it will give 0 and the whole expression will be 0. So these 2 are not satisfied. So the 2 will be exceed for the system, from the system, right? Let's have this 3 number. Similarly, if we plot this 3 here, all the whole expression will be 0 again. So this will be not a region. Let's have the greater than 3 numbers. If that is 4, then this number will be positive, this number also will be the positive, and both positive multiplication are always positive. So this reason will satisfy. Let's see if we consider more than 2 but less than 3 numbers. Let's have 1.5. If we plot this number here, it will be a negative number and this will be a positive number, and positive negative will contain after multiplication it will be a negative number. So this region doesn't satisfy. Let's have less than 2 numbers, that is, let's suppose have 1. If we have 1 here, it will give a negative number, it will also give a negative number. 2 negative number, if both are multiplied, then it will give a positive number. So this region is also satisfied, that is a positive. Let's have the 0. If we put 0 here and 0 here, both will be the negative number, and multiplication of two negatives number will be always a positive number. So the x is included, the 0. So 0 is included in the system. And let's have the less than 0. So we have -1, it will be a negative number, -1, it will be a negative number. So two negative numbers multiplication always will be the positive number. So let's have it. So this region also will be positive, include 0, right? So simply we can say it's a minus infinity and this is infinity. So to express this region, this is the third step, that is minus infinity. This is open, that means the minus infinity is excluded. Always you need to open this bracket, you need to use this open bracket while using the infinity sign. Rather this is a minus infinity or a plus infinity, you need to use the open bracket. Comma, 0 is included, that means minus infinity to 2, and 2 is excluded. While showing the excluded number, that means we are not using the 2 number, we'll use the open bracket. We'll use the open bracket, and this region is not included in the system. So this region is included in the system. So we'll use the union from, that is union, and obviously 3 is excluded, then we'll use the open bracket 3 and to infinity. And as I said that if you are plotting the infinity, we need to use the open bracket. So the solution region will be minus infinity to union 3 to infinity. So we'll solve another example also. Let's solve this equation here. Solution. And this equation, you can see here that it's not in a linear form, and right hand side is not 0, so you need to make it 2 by x is less than 3. We cannot multiply this two thing using the x, that is multiply this thing into x and this thing into x. That is not done in the inequality. Okay, you need to take this 3 to the side. So the next line will be 2 by x minus 3 less than 0. And let's have the LCM here. It will be x 2 minus 3x. So as you guys can see, now it's in a linear form. So the first step is to take in a linear form, and the right hand side will be 0. Second part, need to find the critical points. Critical points. So earlier we have said that we'll discuss about the critical points. So the critical points basically nothing but the behavior of the expression. You can see here that in this is the critical point. So this critical points, this side is all numbers are satisfying this equation, as well as this side is not satisfying, as well as this critical point contain this side of numbers are easily satisfied with this expression that is here, the expression that is, and this part is not satisfied. So it's all about the critical points is that depends the behaviors. So it's influence the behavior of the expression. So that's why these numbers are called the critical point of this expressions, as well as this one. So in this equation we can see the critical points. If we make it 0 is equal to 0, the x value will be 2 by 3. So 2 by 3 will be the critical point for this expression. Okay, so let's have the number system. The second step is to plot in the number system. So let's have the number system first. So let's have a number system here. It's a number system. This is a plus infinity and this is a minus infinity. Let's have the 0 here. This is the exclude sign. If that is included, then we'll grey down the whole area. Let's have this is 2 by 3. We'll plot the critical points in the number line. Let's have this one also here. Okay, let's see which region is the solution region. Okay, if we plot this number in the expression, we'll have a 0, and we need negative number because this expression containing a negative number, sorry, a negative number, right? This region is containing a negative number. So let's see, if we plot this 2 by 3 in the expression, we'll have 0, so it will not include it. Let's have the more than 2 by 3. Let's have 5. If we multiply this thing, it will be a negative number upside and this will be a positive, so this will be a negative. So this region is a solution region because if we plot this numbers in this expression, we'll have a negative number because this will be the biggest number and the sign will be the minus, right? And this x will be the positive because we are using the positive number after all. So we know the solution region is this one. Let's see in this region. Let's have 1 by 3. Let's have 1 by 3 in this region. If we use 1 by 3, then 3 will be cancelled, that will be 1. So the upper section will be the positive one. So the positive by the region is positive, so this will be a positive. So positive by positive, this will be a positive number, so this region will not contain. Let's see 0. Is 0 included? Let's see 0. If we plot this number 0, this will be a 0. Will be, obviously we cannot make this x 0, right? So that is excluded. Let's have the negative numbers. Let's plot of 1 minus 1. So this will be a minus 1, so this upper section will be a positive and the lower section will be a negative. So after all, the whole number will be a negative number, so this region is satisfied. Okay, so we have the region, the solution region. The solution region, that is we said that minus infinity will be using the open bracket, 0 is excluded, then we'll use the open bracket union, 2 by 3 is excluded, comma, infinity will be using the open bracket. So the solution region will be this. Okay, let's have the another example also. Let's have a look in an interesting expression, that is solve x that will be greater than 1 by x. So in this expression, most of the people do the wrong way, that is they cross multiply this thing, that is they multiply x with the both side, but you cannot multiply unknown x in inequalities, because let's see, because if 2 is greater than 1, if you multiply a positive number both side, it will contain the same inequality sign, that is let's multiply 2 with the both side, that will imply 4 and 2. So this will hold, this inequality will hold. But let's suppose I am giving you the minus 2, multiply minus 2 will be having minus 4 greater than minus 2, which is wrong. That means this inequality will be changed, right? So we'll change the inequality here, it will be the less than. So in case you are multiplying a positive number with the both sides, the inequality holds in the same way. But if you multiply an inequality using a negative number, then the inequality gets the opposite of it, right? So that's why we are saying that we cannot multiply a unknown x, because we don't know the specific value of it. It might be a positive number, it might be a negative number, right? So we don't know that, so we cannot multiply a number using this x. Okay, so the wrong answer is this one, that is the wrong. Okay, that is the wrong, this is not 0, this will be 1, that is the wrong answer. Okay, the correct way to do this math, that is, let's see, x minus 1 by x will be greater than 0, then the solution will be x, that will be x square, minus 1 will be 0 greater than, and this will be x plus 1, and x minus 1 by x equal to 0. After that, we can see that the first condition, which says that we need to make it a linear, we have made that expression in a linear form, and RHS is 0. The second point, we need to find the critical points. Critical points, that is, if we see here that x contain minus 1 and plus 1, so need to plot this number in the number system. Let's have the number system here. So plotted the number system here. Okay, so let's have this is 0, this is plus 1, this is minus 1. Okay, so we need to satisfy this expression, which is must be a positive number. So if we give the minus 1 here, it will be a 0, it will be a 0, so this is obviously excluded. Let's see 0, if we give 0 here, 0 here, then 1 minus 1 will be, this is x and it cannot be 0, so this is also excluded. Minus 1, if we give the minus 1 here, this is not minus 1, this is plus 1, so we have this is 0, right? So these critical points are excluded. Let's have the more than 1. If we have more than 1, let's see, if we have the more than 1 here, it will be a positive, here it also will be a positive, and this will be the positive, so this number will be positive. So the negative, so the more than 1 digits will be in the solution region, because it's giving the positive number. Let's see, in between 0 to 1. Let's have a 0.5. It will give a minus, it will give a positive, it will give a positive, so it will contain a negative number, because positive negative will be a negative number. So this region doesn't contain. 0 is excluded. Let's have the less than 0. Let's have between minus 0.5. If we give minus 0.5, it will be a minus. Minus 0.5, it will give a plus. Minus 0.5, and both are cancelled. If both are cancelled, minus minus, then it will be a positive. So this region is also working. This is also working. It's giving the positive numbers. It's giving the positive numbers. And let's see the next region less than 2. Let's give the minus 2. Minus 2 will be minus 3. Minus 2 will be, this is minus, this is minus. Both minus will be a plus, and this will be a negative. So this is not the region. So this is the region, this is not, this is region. So we can see it's alternatively working, right? If that is not a region, this will be a, this will be not, and this will be a. Okay, this is plus infinity, this is minus infinity. So the solution region will be, what will be the solution region? Solution region, that is excluded, right? So minus 1 excluded 0. This is union 1 excluded y, using the open brackets. So the solution region will be this. So that's how you are going to find the solution region of this inequalities while giving a linear form of it. In the quadratic equation, you need to make it a linear form, and then there are lots of things we'll see in next lecture, but here it is. You can see through the examples. Let's have some more examples. Let's solve this equation here. That says this equation is satisfied when x satisfies the solution region. So we need to find the solution region of this equation that is given x plus 4 by x minus 3 less than 2. So easily you can see that the right hand side is not 0, but the left hand side is a linear form. So we make it 0. We need to make that 0. So let's do it. And to have that 0, we will be the, that will be x plus 4 by x minus 3 minus 2 less or equal to 0. And then let's have the LCM here. X minus 3, x plus 4 minus 2x plus 6 less than 0. So we'll be having from here 10 minus x by, so the second point, in second point we need to have the critical points, that is x will be is 10 and other one will be 3. So these the critical points need to plot in the number system. Let's have the number system. Let's have the number system here. We are having the number system. Let's have, this is 0, this will be 10, and this will be 3. Okay, need to draw these things. Okay, so let's see the region here. If we plot, okay, this is less than 0. So if you put 0 here and 10 here, it will be 0. Right? So we don't need 0, we need a negative number, because this number must be a negative 1. So let's put the more than 10. If we put more than 10, it will be a negative, and this will be a positive, so it will be a negative number. So if we put more than 1, it will be a negative number, so it will satisfy the region. That is and then let's see, if we put less than 10 but greater than 3, that is like 5, 5, that upper section will be positive, but the lower section also will be positive, right? So both are positive, so this is not the region. Let's have the 3 here. If we plot 3 here, 3 here, that is, if plot 3 here, that is 3 minus 3, that will be a 0, which is not possible, so that is excluded. Let's have less than 3 but greater than 0. It will be 1, 1. The upper section will be positive, lower section will be negative, so after all this region will be a negative region. Let's have 0. If we have the 0 here, 0 here, the upper section will be 0, upper section will be positive, and lower section will be negative, right? So 0x is included, 0 is included. Let's have the less than 0. Simply we can see if we put less than 0 here, it will give if we put this upper section will be positive and the lower section will be negative. The lower section will be negative, so after all the number will be negative, so this region is also working. So here in the from the number system we can see the region, solution region will be open minus infinity to 0 is included, right? So you can write it as next to 3. So 3 open because 3 is excluded, union this region is excluded and 10 is also excluded, so we need to use the open 10 excluded this thing. Okay, we need to close the using the open bracket. That's it. That's how the solution region will be for this equation. So that's it for this lecture. We'll see you in the next lecture.